Right. So you look at the x and say, I want it by itself. You see divide. You see multiply, and the opposite of multiply is divide. Divide's the opposite. So the idea is, just like you said, Misha, is if you get rid of your fraction, when you're dividing with fractions, you're actually multiplying by the reciprocal. So in other words, to divide, I'll say times the reciprocal, 3 over 1. That's me doing the opposite to tear that number off the x. If I do it to one side, I better also do it to the other side, right? So that killed over there. That became a 1. So now I have x is equal to, what's 9 times negative 3? Okay, sounds good. So again, if it's attached by multiply, you're going to divide. That's the opposite. If it's fractions to divide, you multiply by the reciprocal, because that's how you do fractions. Or if it's a number, you just divide by whatever it was, a number that's not a fraction. And then, of course, remember a second ago I reminded you guys that that's completely different from a problem that was just plus. Like if you would have had, I don't know, negative 1/2 plus x equals 1/2. Your strategy there is completely different, isn't it? Because you still want x by itself, but this thing's attached to Luther. It's attached with an and. When stuff is attached with and, you think plus and minus. That's what you do to tear it off. So with this right here, I have a negative. What's going to be the opposite of a negative 1/2? Okay, so you plus 1/2. What you do to one side, you have to also do the other side. So when I say sign, I'm talking about that equal sign. You're always doing stuff on opposite sides of the equal, because that keeps your stuff true. It keeps your equal sign A-okay. So that cancels. You get x is equal to 1/2 plus 1/2 is 1. And you can always check these. You can always check to see if negative 27, for example, is a solution of your original by doing what? Yeah, plug it in for x. Substitute it back in. And when you multiply negative 1/3 times negative 27, you get a 9, you're right. So to check it, you can always do that. To check and see if it's a solution, we'll say negative 1/3. In place of x, we'll plug in our proposed solution, equals 9. And we're looking for a true answer. If it checks out in the end, it was right. So let's see what that does, doesn't it? So that comes down to a 9 to cancel. So we get 9 equals 9. It's true. So it's a solution. We did a good job. Yeah.
All you have to do is just flip if you don't ever divide it.
Okay, well, actually, technically, you're always dividing it. But when you flip the fraction, that is dividing. Remember how, okay, I'm going to say remember again, because that's what I do. I tell you to remember. Let's say, I'm going to write it out while we talk. Let's say you had 1/2 divided by, I don't know, 3/2. Remember when you have fractions and you're dividing, what did you actually have to do to this? You had to change that to multiply and flip the thing? That was the same thing as dividing, right? Multiplying by the reciprocal. So technically, Cal, up here, yeah, you are actually technically dividing. But, yeah, does that make sense? Is it helping? Times by that's the flipped version, or if it's a number, divide. I guess the reason I started emphasizing that, because when I taught you guys last time, I didn't really say a lot that it was dividing when you were doing that. But I saw some people getting confused on when to do what. And I just want people to remember that the reason you're either flipping it or dividing it is because you are doing the opposite of multiply. So, to the new stuff. Basically, we're just going to start combining some sets. So, for example, if we had, I'm going to kind of teach you by just working out stuff and making sure we can talk through it. If we had 2x minus 5 is equal to 25. The question is now, can you solve for x? Can you put those steps together? And I'll tell you a strategy for when these things get more complicated, for when they start getting more than one step. Strategy. You want to isolate x by killing what is least attached first. That's the easiest. Remember, as long as you do the same thing to both sides of that equal sign, you can do whatever it is you want. Even if it's not something helpful, you can do whatever. But the strategy to getting your answer in the easiest way is to isolate x, get x by itself. You guys want me to say canceling or killing? What's your favorite? By canceling, the stuff that is least attached to x first. And I used to always joke with my students, and because, you know, I always like to say kill, just because some people get so much anger towards math, they like to think about killing numbers. So I used to always joke with students in other classes and say, just remember, like, if you're coming in for an attack on x, you're going to get the stuff that's looser, the stuff that's further from its boundaries first as you work your way into what you're getting to, the x. So, for example, here, in this, our goal is to get x by itself, right? We want to know what is x. What's loose attached? The 2 or the 5? What's the most loosely attached? The 5, right? You see how if you even look at it visually, one's kind of tight right there touching the x, and the other one's just kind of holding on? That's an and. It's a plus or a minus hold on, so we look at the opposite. What's the opposite of minus? Plus. So to tear this thing off, to cancel it out, we'll do plus 5. What you do to one side, you have to also do to the other side, right? So we'll bring down what we have left. We have 2x still. I'll just copy that down. The equals comes down. And 25 plus 5? Sounds like a 30. Everybody okay so far? Do you see how the neatness of this would make a really huge difference? So be really careful if you copy the stuff down and you show stuff canceling. My goal is still to do what? Get x by itself, right? Yeah. So let's see. We have something attached to x that we want to cancel. So 2. How's it attached? Multiply. The opposite of multiply is divide. So let's divide to tear it off. If you do it to one side, you have to also do it to the other side. So because that was multiply there, we chose division. They were opposites. So now we're going to have x is equal to 30 divided by 2. What do I have? 15.